There's the note well that you have read and seen and know by now. Please close the doors if you don't mind. And stop talking. Unless it's about the note well. A repeat of the first session. We have Barbara that is taking notes for us. I believe Shuping is being the chapter scribe. Thank you very much. Blue sheets are going around. Here is the agenda. We have 2 working group drafts. It's items. It's the fragmentation errata. And going through those together with the AD. It's the Pref 64 work. And we have a set of active individual drafts that we'll go through, and then a set of lightning talks afterwards. I also wanted to mention that during our working group chair meeting on Wednesday, the RFC editor updated us on the RFC format project, and this is something that is going to come to all authors, that the format, we're moving to V3 of the format, so there's a new version of the XML to RFC tool, and there's now some small changes, including, you get a SVG graphics, lists have changed a bit, and I can even put my surname in correctly now with the O/ in there. So I'll just make a document, to prove that works. Okay, Bob, I think you are up. Here's the clicker, and please stand on the cross.
The target position. So I'm going to talk about the fragmentation errata for RFC 8200, the IPv6 spec that we did, what was it, last year? Or in the year before that, and the year before that. So RFC 8200 was published as an internet standard. I guess it's just standard, but July 2017. And it included fragmentation updates from 4 RFCs, and as the document editor, it was quite challenging to bring all that in and have coherent text. And I think, based on the errata, I think we didn't quite succeed in doing that correctly. But it required extensive changes to the fragmentation text. And errata 4. However many that is, a bunch of errata were filed in October of the same year, and it's taken a while to get around to look at them very closely. So the underlying problem is that the fragmentation offset defined as pointing to the fragmentable part, which was the way it's written in the spec that we were updating, should instead point to the extension and upper layer headers, not to the part after that. And so in order to do this directly, the text will need to change in 4 places. That's actually, there's actually one that the errata missed, or there should have been 5 errata. There were other changes proposed in the errata beyond fixing this problem. But let me first talk about the last errata, because that's the simplest one. So the errata proposed changing the figure of the reassembled packet from the stuff after the extension and upper layer headers from first fragment data to first fragment. I don't believe this is actually correct, because it's not the whole first fragment, it's just part of it. So I think it's actually correct to say data. That's why it was done that way. So I don't think that's a change we should make. So I'm going to go through the direct text changes based on the errata, and then Oli and I have been looking at this, and he made a suggestion which I like, that is a different way of solving this problem. So the first one, and this is the one that was missed, it's on the first page of the document where it defines fragment offset, and that also has the same problem. So instead of relative start of the fragmentable part, it should be relative to the start of the extension and upper layer headers. I mean, so the changes are mostly all like this. The next one is on page 18, second paragraph from the bottom. Again, changing it to be relative to the start of the extension and upper layer headers. And the third one, it's also the same kind of change. Page 19, fourth paragraph from the bottom, same sort of change. And the last one is slightly different. The first part changes in the same way. So in this case, it's adding extension and upper layer here. Instead of changing it, it's because it's referring to both. And then you also thought rewriting the last sentence, it's clearer if you say the reassembled original packet instead of fragmentable part. And the other related change, if we're going in this direction to make, would be on page 15, second paragraph, the next header definition. It's sort of, instead of saying identify as the initial header type of the fragmentable part, it should say initial header type of the next header value that identifies the first header after the per fragment headers of the original packet as defined below. So let's get the doors closed, please. So another approach, I mean, this text is very awkward. And so this is actually, I give Oli all the credit for this, and I like it a lot. No, for a better way of writing than what we all came up with, since you all approved this and the AD reviewed this and the ISG reviewed, this sort of interesting that it got this far this way. So the problem was caused because we added extension and upper layer headers to the figures, and a few places in the text. So a lot of the text is talking about the figures. And so the idea here is to fix the place in the text where it actually tells you to put the extension and upper layer headers is actually only in it's like part 2 of the text where it says how to create fragments, or particularly how to create the first fragment, and that's where it says it. So Oli's observation was, if you go back to the text and the figures from before we did this change, that it actually gets a lot simpler, and you just add the words, make it very clear in the text where you're creating the first fragment. And so we took a cut at this. So I have 3-page, can you read this? Okay, well, at least I think you can, it's very clear on the screen up here.
And we did it from the agenda page.
So these slides are up on the agenda page if you want to look at them. I mean, we're obviously going to send this out to the list. We're not just going to declare final approval here. So, but you can at least you can, I think, get the idea of that the figure is now back to per fragment. Oh, that's, sharper on my screen. Yeah. But you can see it changes, it takes away the extension and upper layer headers, and it's just talking about the text. And so, and then there's also some changes to the text. Let me just go, can you zoom it back? Oh, there we go, that works.
I can. It's a little hard.
We need higher resolution displays.
Yeah.
So this is the next page, and you can see these are just changing the figures. And then, so the text in, it's sort of the bullet 3, where it starts talking about extension headers, because it's not just done in there is actual text that says what to do. So we moved the the paragraph that defines what these, the extensions headers are, and upper layer headers. The definition that was in the current document earlier here, but it fits here very well because you can see the beginning of that paragraph says extension headers, if any, and the upper layer headers. So these, and the headers must be in the first fragment. That's the behavior we're looking for. And then I think there's one more. Yeah, and then this is also just makes the figure of what the reassembled packet looks like a lot simpler. So, and then, yeah, there's something at the end, but that's just a remnant of me trying to produce a 0 and an 01 draft to be able to see the changes, to be able to do this diff. So I think this is a much better approach. I think it actually makes the document simpler, but it's still correct, and it still makes the change, it continues the change that the extension headers and the first upper layer header are in the first fragment, just because that was actually text. It wasn't in the it wasn't the figures. Figures were there to illustrate it, but it was, you actually go back. I mean, it's this, item 3 that, it's defining how to create the first fragment. That's where the real protocol definition was. And if you notice, there wasn't a problem with that text. So it was the text that was trying to explain the figures and where the pieces were. And that just gets a lot simpler if we go this way. I mean, we unfortunately didn't figure this out the first time around. Okay, so see if I can, yeah, you have to scroll up.
A little bit more minus.
There we go. That's pretty good.
Yeah.
So we think that the alternative approach is actually better than making the specific changes to the text, which in some ways makes it more complicated. We clearly think that the working group needs to review these carefully. We don't want to do this again. And it might actually be good for someone to spend some time and with, the text that we agree to, make sure, actually go and see if you could implement this and if it works in the way it's supposed to. Joel?
So that leaves to the obvious, assuming I agree with you, because it seems like a sensible approach. I'm just a little uncomfortable with publishing that thing that results as an errata.
So next slide.
Thank you.
It's a good point. Okay, and so the errata 5173, we think that should just be rejected. And we don't think that's correct. So, yes. So I think. Thank you. I think 4 different ways we could go here, how to handle this. The first is, so the first is to accept the errata with the changes here and mark it held for document update. We would need to figure out how to describe, either just include a whole new section of text or what the changes are. And, you could imagine having a script that actually you apply to the old text, but that's, maybe problematic. But there are 3 different errata here, so it's a little complicated. The next approach is to reject all of these errata, create a new one that includes all of the text, basically consolidated into one errata. So if someone looks at the RFC, at least on the tools page, or they look at the errata, they will see the new text. And that, I think, has the nice part about tying the changes to the current spec. And there is a new set of errata tools that are, I think, I'm not sure the exact status, but I think they're coming pretty soon. And this may give us some better ability to do this. The next approach is to publish a new RFC with, basically an update that updates section 4.5, the part that defines the fragmentation header, of 8200. It just says this replaces section 4.5 with this text. So it would be a complete set. And then the 8200 would point to the updating document. And then the last change is to just do a whole RFC 8200 bis. Obviously, it would be published with some other RFC number. So my recommendation is to either do the, find the best way to do it in the errata system, or publish a new RFC that updates 8200. Of course, I note there is a course, do we want to deprecate fragmentation? That would sort of solve this problem quite well. We just say, don't do this anymore. But
Suresh Krishnan, AD hat on. I really like the hold for document update, like approve the errata as is, like hold for document update. And probably do the third thing after at some point. If you want to do the update, let's do it. And one thing, since you talked about the RFC like format changes too, there's also like a project ongoing to do inline errata for the RFCs.
yeah, that's what I was talking about.
Right. Like, so I think it's, if you do the verification first, like make sure things stay, like instead of filing a new one, just like put it in the verifier notes, maybe we can actually put it in and approve it. And then do the 3 if needed after. That would be my preference.
Okay.
So Suresh, since we have 3 or 4 errata that is essentially for the same issue, are you proposing that we accept those 4 errata and put a new text in one of them, all of them?
3. There's 3 that
for
apply.
approval, yeah, like, and so each of them, so when you go and verify an errata, right, you can put a verifier note in there, like, which could suggest different text. So I would put it in and say like, hey, this is the text to be used or something, right, in there. So it retains a record of like what Fernando suggested and what we're putting in to solve the same thing, like what we meant to say. So that's what I think is the cleanest, because like, or we can close this and do the other one, but I think it's like a little bit more overhead for me personally.
Well, one problem I think with the 3 is that there's no direct correlation between the 3 and a fix. I mean, there were more problems, found when Bob and I reviewed this. So either you end up with 3 errata with the same verification, new text, which would be a bit strange, or could you do one and point that one to the other ones in a verification text or something?
Sure.
But
shouldn't be a problem. We can talk about the logistics, but the thing is, like, we know this is right, this change is, like, we need to make a change. And if you say verified, like, when the inline thing happens, the other thing can proceed in parallel. So, like, people can at least see this as being changed. I just don't want to wait for 3 to happen and, like, wait for, like, let's say a year, right? Or maybe faster, right? But I'm just expecting a year, like, for the whole thing.
Mhm.
So let's keep this verified, and then people at least see there's errata exists. When they go to the RFC page, they're going to see the errata that exists and it's been verified.
right. So you would suggest we take
1 and 3.
Bob's suggested verification text, and we run that through a cycle on the mailing list, and then we send it to you and ask for that to be put in the verification. Yep.
Okay, that's good. And just so I can say it out loud, and I do not recommend that we do an RFC 8200 bis. I think
Thank
that
you.
would be bad, and for several reasons, and it seems very excessive. And once it's open, it's going to be, we'll get to redo a whole bunch of debates we got to do the last 3 years. So let's at least argue about new things. Yeah. Good.
Okay.
Any other questions? So I think the next step is to send out to the list. I have now I'll send out both. I'm not going to submit this as drafts, but I'll send out the text, the original text, this new proposed text, and a diff. And we would like people to review it closely and see if it's correct and we didn't miss anything.
Yeah, it would be great if different people could implement it as well. So,
Yeah.
in the next fortnight, please.
Good. Thank you.
Okay, Jen, you are up.
Okay. Raise your hand if you have no idea what this draft is about. Oh, cool. I need more slides then. Okay, to make the long story short, I hope you know what NAT64 is and DNS64 is. And unfortunately, currently, if I deploy NAT64 and DNS64 in the network, some hosts might want to synthesize themselves. For example, if they are running validating resolvers on the host, but they have no idea how to find out what prefix to use except using some tricky things like RFC 7050 when you're trying to resolve IPv4 only name, get back quad A, and guess, so probably that's what our prefix is, but in this case, you're using something which you got from DNS to do DNSSEC. So it's a kind of, I see some security issue here. So what we're trying to do, we're trying to get an array option, which will allow routers to tell hosts what NAT64 prefix is used, because it does make sense, because the router knows where to route that prefix. So it's a short story of the last 2 meetings. So 03, which I just submitted a couple of hours ago, actually not so many changes. We added support for non/96 prefixes in case someone would need it. So as discussed on the previous meeting, we decided to have 2 option lengths. If a prefix is /96, then we have short option of length equal to, and we only keep first 96 bits of the prefix. But if you need longer prefix, you just add prefix length at the very end and have some reserved bits. So it would allow us to save some bits on the wire, because somehow we have a feeling that /96 is the most common use case. So in most cases, you would not need the longer option. It was a comment on the mailing list about routers verifying what other routers are sending on the same link. And actually, it's in line with Slack RFC 4861, which does recommend routers to verify options sent in array. So we added a text which saying routers should look at other arrays received, look if it's the same set of prefixes with non-zero lifetime, prefix with 0 lifetime. Don't do anything except maybe log it if you want. Because, yeah, obviously, routers should not make any conclusions, but administrators might want to know if there is some inconsistency. Text explicitly says that if router knows about PVDs, it should only compare information in the same implicit or explicit PVD. So it was supposed to be unresolved issue slide, but now it's kind of resolved issue slide. Mark Andrew suggested that we might want to have exclusion list, which will tell host a set of v4 and v6 prefixes for which synthesis should not be done. So actually, it's not exactly correct slide. I'm missing last bits of the prefix here. But yeah, so Mark suggested to use these reserved bits to add DNS name in DNS wire format. So we've discussed it a bit. So we believe that there is no real reason to keep those things in one option, because it makes the option format a bit complicated, which might actually slow down the implementation and deployment. And also, I personally have issues with operator telling me that IPv6 is too complex and difficult to understand. So I prefer to keep it simple. Also, exact semantic of what of this option and what host is supposed to do with it is not actually clear, because there is an experimental RFC for APL. And so, yeah, some clarification would be required to explicitly specify the host behavior. Also, actually, this option, it would be particularly useful in IPv6 only networks. In IPv6 only network, if host decides not to do synthesis for some names, it's not clear what the host gonna do. Like, there is no v4 connectivity. End of story. So also, I did some math. I might be wrong, but it does not look like we actually saving bits on wire unless the DNS name is really short. Also, it's a bit unclear for me if it's a good idea or not to refer to have a down ref to experimental RFC in the standard track. And also like side effect, it's not really important, but still, if you have a separate option, some systems might just prefer to still do 70/50 or use PCP or whatever, but still use this APL option from the network without actually supporting Pref64 option. So we discussed it with Mark, and he just posted a draft. I don't think the draft made it to the 6-man mailing list, but here is the reference. So he proposed a separate array option for APL. So again, as I said, I don't think he forwarded the draft to the mailing list, so probably just have a look, and I am soliciting feedback on his behalf because he could not be in this room right now. So the only thing in this case, we are not kind of binding together, not tying together Pref64 and APL, but again, I really do not see the use case in situation when we need to have separate prefixes, more than one prefix, and separate APL lists. Honestly, like real operational use case is unclear. So, any comments, questions? Otherwise, maybe we think it might be ready for the working group last call.
So could I get a show of hand of people who would be willing to review and is interested in this? 2, 3. Really have liked a few more. There's one in the back, yeah.
People normally read drafts on the last call, right?
Yeah, excellent. Okay, good. So we'll send out a working group last call for this draft and ask for 2 volunteers at least to review it thoroughly. Super. Thank you, Jen. And the next one is Gory. He is here. If you stay within the time limits, you can even get your adapter back.
Thank you. Incentives. Okay, so this is fun. It's 3 stories, 3 jumbos. Here's the giant African elephant jumbo, which is a big Victorian story or a big American story with Barnum's Circus. And we're going to talk about RFC 2675. I'm Gory. My co-author is Tom. This is a story about the first jumbo frames. Jumbo frames are lovely. They're very, very exciting. They're big Ethernet frames up to 9,000 bytes. Jumbo frames exist. One of the 3 jumbos I will insist does not exist. But these ones do exist, and we like them. Jumbograms. Well, jumbograms are an IPv6 function where you can send a packet greater than 64 kilobytes. You put that packet into a frame, and you send it across the network. We don't have a layer 2 that takes a 64 kilobyte frame, or even a bigger one, so it is a little bit difficult to transport. At one time in the world of IPv6, there was some link layers, at least InfiniBand had a way of moving these packets. I don't believe they now do. Current status, 2675 is referenced by 17 RFCs. There are 3 active internet drafts, and in the transport area, people keep asking us about them, what they should say about them, what they should do about them. Our transport advices don't touch them at all because we don't have any checksums, we don't have any protocols that are safe to use with them, and we don't have any way of sending them, so that makes them not very attractive. Tom's a different viewpoint. Tom's works with FreeBSD, and he looks at the NetDev code, and there's a whole pile of statements in there based on the RFC, which are currently in your FreeBSD stack. They don't want to maintain this code. They have some interesting comments. You can look on their list. They range from burn it in fire, or please remove it, but we can't remove it because the RFC says it should be there. But we can't send the packet. So, questions for 6-man. The story of the Victorian jumbo is it got hit by a train and had a very sad ending. Should we continue to make try to make RFC 2675 historic? This draft that I've talked about tries to make it historic by listing where it's used and what happens. Or should we leave RFC 2675 alone? we have various opinions. Oh, Brian.
Yeah, hi, Brian Carpenter. This is all partly my fault because at the time this was invented, I was in charge of the networks at CERN where people were very concerned about extremely high data rates within the data center. They still are, by the way. And this seemed like a wonderful idea because it matched very well what Hippie and InfiniBand and one or two other technologies whose names I've forgotten, scalable, coherent interconnect, I think, were capable of doing. The point is, I don't buy the argument that this is damaging to BSD or any other stack implementation because this is an IETF standard which is entirely optional. You don't have to support it. If you do support it, you have to do what it says in the RFC. But if you don't support it, you don't have to do anything, right? Except, if this particular format of packet arrives in your stack, you send back an ICMP message if you can be bothered, I suppose. So I don't see why it's damaging to stack implementers unless they don't understand the voluntary nature of all IETF standards. On the other hand, the use case has never changed. There are still people who want to do extremely high capacity transfers inside data centers. So personally, I would just leave it exactly where it is and send a letter to the BSD developers pointing out what voluntary standard means.
Hi, I'm Bob Hinden. So just to ask a clarifying question based on what you said. So regarding, say, the free BSD code, is it a fair assumption that because there aren't any links that you can test this with, if the chance of this code actually working is sort of low because it hasn't been really exercised?
There are people who touch and shove on it, so the code compiles, it still goes through the checker, but it does require you to allocate buffers and other things in ways that people don't really do because they don't really have any way of testing. So I wouldn't like to bet that the code works, and it certainly hasn't been reviewed for about 10 years or so. Yeah, so
Yeah, I mean,
it's very old code that is never exercised.
yeah, code that's not actually used doesn't tend to get better. So
Yeah, okay. And
Ron Bonica, Juniper
Yes.
Networks. I would vote for moving it to historic for a couple of reasons. First, the initial motivation for it. Although Brian has a good point, the initial motivation has gone away. Modern line cards can process many millions of packets per second. There's really no need to send a packet that long. You can send 2 packets. Second, it's a good thing to reduce the real meat to fluff in the RFC series. Deprecating something that we don't actually use is a good thing. And what's more, doesn't this use a hop-by-hop option? And aren't these the options that we just emasculated? Maybe this is a good one to make historic.
well, it would probably only be able to be used between a pair of link endpoints. So, but yeah.
Yes, my name is Ole Trant. So I think I would more second Brian's point. When I implemented V6 in iOS for Cisco, it was inconceivable to implement this at all because we didn't have any buffers large enough, nor did we support any link layers that can do anything anywhere near this. Is there any way we could solve this, either by creating an applicability RFC or make the message clearer to implementers? Now that said,
IETF transport people would do this. I explicitly say this is
Right.
for use in controlled environments, and if you're doing it, then be careful of these things like to apply checksums which actually work over the chunk of data you're doing, and beware of big buffers, and then write an applicability RFC. I don't know what you would do.
But that said, though, there are sort of funky stuff going on. Take container networking, for example, where you do, plumb things on the same host, and you might, we certainly run that today with 64K MTUs. You could certainly imagine someone wanting to do that with a 4 billion byte MTU if they want to do so. I'm a little uncomfortable saying this is historic because I would rather sort of can we make it in some fashion that it doesn't create that harm a bit rot that you have in this particular implementation.
Okay, I hear.
Lorenzo Caludi, I think the question is, do we, can we unhistoricize it if once it's historic?
Yeah, just we would use an RFC number to do it, but that's not that difficult.
I don't see.
I don't think we can unhistoric an RFC number that we've made historic.
It's just status changes.
Which is status change. We could status change. Oh, okay, whatever. Sorry, carry on.
But I don't see this happening in the next 20 years, maybe. But maybe after that, the question is, do we run out of V6 space before this becomes relevant? That's really it. So, yeah.
Okay.
How much work is it to make it historic? Do we need to use up a lot of working group time and do IETF last call? And so
there's 3 ways to do it.
This is Brian Carpenter again. I'd just like to read the relevant paragraph of RFC 2675. Says the jumbo payload option is relevant only for IPv6 nodes that may be attached to links with a link MTU greater than 65,575 octets.
Yes.
That is 65,535 plus 40. The jumbo payload option need not be implemented or understood by IPv6 nodes that do not support attachment to links with MTU greater than 65,575. So, I don't understand why anybody, including a BSD developer, would bother to implement this thing unless they have to implement a driver for a link that supports 65,576 bytes. That's why I don't understand why we need to do anything except point the BSD people to that paragraph, which says, don't bother with this. It's not your problem.
This conversation will probably be noted, and we could probably make results on the basis of what's being talked about right now when we get to Suresh.
Eric Klein, I tend to agree with that comment. Also, I would say that even though there may not be links where this could be transmitted, there might be loopback virtual kind of links, right?
That is where where we tested the code and found the horrible problems that occurred when you did try and use it in loopback and try and do the buffer management and what the heck and all the other gremlins that crept in, which is where this story started.
So that implies that it is indeed testable. Thank you.
Right, and does it work? Yeah, whatever. Yeah. Whatever you build it as when you do. You'd be well advised. Please do that. Yeah.
David Lamparter. I'm waiting for anyone to step up and say, I'm using this. And I don't expect there is anyone. I'm not a big fan of leaving dead specs around, and this does count as a dead spec, I think. And even if one person uses this, I think they're okay with implementing an historic RFC. So I rather have it moved to historic just to flag that. Yeah.
Suresh Krishna, no hat. No hat. No hat.
No hat.
Yeah, no hat. Yeah.
No hat.
So I think we should just let it be. Don't do anything. I think I'm in agreement with Brian. It clearly says if you don't have to do it, or if you don't have the capability of doing it, don't do it. And if somebody tries this with large MPUs, one thing I was specifically talking about all the stuff. I've seen stuff using MEMIO, for doing container pipelines that could potentially use this. And if this breaks horribly, somebody needs to fix it, right? Rather than taking it away. So I would just say let it be, and then if something breaks, we fix it. I think it's an implementation that needs to get fixed if it uses it. So, but with the AD hat on, whatever the working group does, I would probably go for the status change document as a way of doing it. I think it was option number 1.
Yeah.
It's the easiest way. It's completely out of band, so I don't need an ID to go through the process. And at this point, I debug this. I did this for IP version 5 and 7 and 9 and so on. So I know the process now, and I'm around for a bit. So I'll just make sure this gets done. And now it even goes to IANA to mark it as historic. So previously the process was never tested. So IANA never marked those things as historic because they never got a review mail. So now it's all debugged and we can do that.
Okay. We need to decide what to do with other documents as they appear and reference this as well, because people are still writing transport documents saying that you have to support this, which kind of which is super, but they don't consider the checksum or any of the other implications that go with it. So, Yep.
So
Think about that, and I'll take this output we got from here.
do you want to
Can I-
send us that list perhaps of
Of
new
issues?
documents at least that reference this, because that has to be, cleared up.
Okay, fine.
Yeah, can I just suggest, I would support a short document saying that, basically.
All right, yeah,
Which
sure,
would
I can
be
do that.
update to 2675, so it
Mhm.
would appear in the record, and would say, by the way, what that means is don't do this.
Yeah, yes.
But seriously, then it would appear as an update, and you could point it to
Okay.
people as a current RFC.
And Brian, I assume you're willing to help co-author that?
If we were to write it, would you help us do it?
I'll have to check with my lawyer, but yeah, I would think so.
Right, fine. Can I take my adapter?
Please take your adapter. Thanks a lot for lending me that. I think, if I remember correctly, it is Ron that is up.
Could you book me halfway through? So we'll stop for questions.
Yes.
Okay. Ron Bonica, and I've got 3 drafts in this working group. One about a compressed routing header, one about a destination option to be executed at the end of a segment routing path, one about one to be executed in the middle of a segment, at the end of a segment in a segment routing path. And this time around, I wrote an overview document explaining what these 3 things are doing and why they exist. We're going to go through the overview document for a little bit. So we have these things called segment routing paths. They provide connectivity from an ingress to an egress, and they contain segments. There are instructions associated with each segment. And there are 2 kinds of instructions: topological instructions and service instructions. So let's talk about topological instructions. Every segment in an SR path is associated with exactly one topological instruction. It's executed at the segment ingress node. It determines what the segment egress node is and how the segment ingress routes the packet to the segment egress, either strict or loose source routing. And some details, what it does is, what the instruction does is it overwrites the destination address and it forwards either through an interface or through the least cost path. And we encode this in an IPv6 routing header. You've seen that presentation before. It's the compressed routing header. Then we have these things called service instructions. They augment a path. They don't define a path. And we have 2 kinds of service instructions. Per segment service instructions that can be executed at any segment endpoint. They typically don't influence routing. They don't influence whether you go left or right. Some examples are expose a packet to a firewall policy or expose a packet to a sampling policy. We encode those in a destination option header that precedes the routing header we just talked about. Why do we do that? Because the destination option header is processed at the egress of each segment. Then we have per path service instructions. They're executed on the path egress node, on the egress of the final segment. They typically de-encapsulate the packet and demultiplex the payload. An example, de-encapsulate a packet and forward the payload through this interface into this VPN. Typically, they look an awful lot like MPLS service instructions in L3 VPNs or in EVPNs or something like that. And we encode those in a destination option header that precedes the upper layer header. Why did we choose to encode them there? Because the destination option header that precedes the upper layer header is processed on exactly the right node on the path egress or on the egress of the last segment. Now, why did we go through such pains to decouple service instructions from topological instructions? Okay. One reason is so that we could use the right header for the right kind of instruction. When we compare topological instructions with routing headers, they're both intended to affect routing. That's why they're called routing headers. And they're executed on the segment ingress node. Why did we use the DOH preceding the routing header for per segment instructions? Because they're executed on the right node. Same question for the destination header preceding the upper layer header for per path instructions. It's because they're executed on the node where we want them to be executed. We call this SRv6+, but in this formulation, we have simplified identifier semantics. In SRv6 and SRv6+, we have this concept of a SID. We have this concept first of a service instruction identifier. A service instruction identifier identifies a service instruction. It appears in the destination option header, and it's not polluted with SID or IPv6 address semantics. We have a SID that identifies a topological instruction. It appears in the RH and only in the RH, and it's not polluted with SII or IPv6 semantics. We also have an IPv6 address that appears only in the IPv6 header, and it's not polluted with SID or SII semantics. It has exactly the semantics from the IPv6 addressing architecture. An IPv6 address identifies an interface. And we're very careful never to copy an identifier of one type to a field that's meant for another type. For instance, we have SIDs in the routing header. We never copy a SID to a destination address. In fact, they're different lengths. We couldn't do it if we wanted to. Why do we do that? Well, it's the same reason you don't copy a pointer of one type to a field that dereferences through another type. It's kind of asking for trouble. So, what is the cost-benefit analysis here? Well, the cost is because our SIDs are different from an IPv6 address, we have another layer of indirection. A SID is a key into a data structure. We call it a SID fib. The SID fib maps a SID to an IPv6 address and an instruction. You do a lookup in the SID in the SFib, you find the address, and you copy the IPv6 address field to the destination address of the IPv6 header. We have one more routing header type, the CRH, albeit it's a simpler one. It has fewer fields than the SRH, and we have two new destination options: one to carry segment instructions, one to carry path instructions. Benefits, ping, okay, half my time is up. Okay, we've already talked about the RH. It's simplified, no tag, no TLVs. The SID identifies an instruction. It does not contain an instruction, so it can be encoded in relatively few bits. And because the SID is short, the routing header can be short even when it contains very many segments in the SID list. And there's no need to augment OAM, because the only thing that ever appears in a destination address is an IP address. So ping, trace route, all that stuff works. The other good thing is you can mix and match. You can use the routing header to route, but you can use a VNNI to demultiplex if you don't want to use the destination option. So if you're doing EVPN, you can have an IPv6 header followed by a routing header for traffic engineering, followed by a VNNI if you want to do just plain old EVPN. Or let's say you don't want to use a VNNI, but you want the traffic to take the least cost path. IPv6 header with a destination option, you don't need the routing header. Decoupling, you can use only what you need. Overall simplicity, the existing drafts kind of cover the entire subject. Here's a little comparison of CRH lengths per SID versus SRH lengths. Now, granted, in the last 2 weeks, there have been two proposals for making the SRH more compact. So those numbers are a little bit old, but they were correct the day I wrote the slides about 9 days ago. We have a couple implementations, one in Linux, and it has the control plane with it, ISIS and all that good stuff. We have a Junos proof of concept coming soon. And the next steps are to progress the drafts. I'm not even going to ask for that because the first one has to go first through spring. Anyhow, questions?
Yeah, so just to add, I mean, so we went to the spring working group where you presented same.
A good time was had by all.
Yeah, so I mean, it didn't seem like there was a lot of enthusiasm to take this on in spring, or at least now, or something. So.
Yeah, there've been discussions since the group.
Okay, well, that's good, but that's, for us to spend a significant time on this, I think, we're going to need to hear from Spring that it's something they want to investigate.
So Suresh Krishnan has responsibility here. So like what I said in spring, right? So like similar to like what we did with SRH, like we didn't like allow any kind of follow-up work for SRH until the SRH thing was done, right? And so I want to go pretty much the same way. So like, Spring tells us like they're going to adopt this thing as like a kind of architecture, and they sign off on it, and then we start doing the follow-up work that's required to implement it. Like, so that's kind of like what we agreed upon, and that's what I said.
Yeah.
I think that's what like Bob was alluding to as well, right? So just like a gatekeeping function, and it's not here, it's in Spring. So.
And the gatekeeper is about to step up behind you.
Martin Vigoureux, Routing AD for Spring. So you should expect a message from the Spring chairs soon on the list to kick up a discussion on the next steps for that and other proposals that have been discussed.
So I guess the bottom line is subscribe to the Spring mailing list if you don't already.
Super.
Thank you much.
Thank you, Ron. Our next speaker is Safar. You have 10 minutes, I believe.
Thank you. So I'm going to present SRv6 O&M draft on behalf of the co-authors and contributors. This work started about 2 years ago, and it has been presented to Six-Man as well as Spring Working Group multiple times, including exactly 1 year ago when we were here in Montreal. And I had a presentation on Spring yesterday, and the decision was that this is an ONM, this is a Six-Man document. So here we are. So with these things, there has been a lot of good comments sent on the mailing list, and they have been incorporated thanks to all the working group. This has been deployed. The draft-based implementation have been deployed in multiple production networks, including SoftBank, China Telecom, and Elite. The details are available publicly in the draft that is mentioned here for deployment status. And there are 10 platforms that support this implementation of this draft. This is also based on the public information, which is listed as a source. And there has been interoperability done on this draft, and this was done publicly in March 2018 by EANTC. Then it was showcased in April in MPS World Congress. There were additional interoperability that was done privately, but for the public, the information is available in the source draft that is mentioned here. Now, coming back to draft summary is very simple. It is relying on existing ICMP mechanism. It does not define any new mechanism for ICMP. When we have SRv6 deployed, there obviously all nodes are not SRv6 capable, and they work seamlessly. Then, for some use cases, define the use of the OBIT. If you remember, the OBIT used to be in SRH draft. It was there for a very long time until the last call, and the comment was that it needs to be moved to O&M draft, where its usage is defined. So it was moved. And it also defined two sets to behavior for O&M. Using this information, it provides some illustration on how we can use these tools for doing ping end-to-end, segment by segment, trace route, hop by hop, segment by segment, and also how is RFC 8403, which is just part monitoring, is applicable. With that, and multiple production requirement and interop done and various implementations that are available, and this work has been mature, we would like the working group to adopt this today.
Greg Mirsky, ZT. I have a couple comments. First, I think it's a useful document, and it addresses tool that is probably the most used OEM tool ever, traceroute and ping. So definitely operators will appreciate this work. Though I want to point that there is some inconsistency how their draft is named and what it addresses. So it refers to SRv6 OEM, but I believe that SRv6 OEM is broader and than just ping and trace route. So might be somewhere along the way working on this draft, the name can be more targeted towards their scope of the document. I think that looking at what requirements for adoption, that draft is ready for adoption, call, and then working group, we can discuss whether, all-bit is the right way to do it, because so far as I know, ping and trace route in other networks work without all-bit. So why it's needed, that's something that we can discuss as a working group.
Yeah, thanks, Greg. On the name change, 100% agree with you. Please suggest something. It could be changed, and it becomes a working group document, and working group can contribute to it and make the changes like you're proposing, so we can debate more next time.
Gaurav Davra, LinkedIn, and speaking as a contributor to this document, as Greg said, operators will appreciate. So my appreciation for this document. I think it's a useful work, and we have plans, something which we can use in our production network.
Ron Bonica, no particular opinion about whether it should progress or not, but a question about a word you use in the draft, and that is to punt a packet. I'm assuming to punt a packet. I assume you're talking about punting from the forwarding plane to the control plane. And I'm assuming your assumption is that the device that's processing it has distinct forwarding and control planes? Not all devices have distinct forwarding and control planes. And it's kind of a discussion about an internal behavior. Maybe the OEM should only talk about externally observable behaviors.
Ron, if you're suggesting some other word, or we can wordsmith it. Yeah. Perfect. Thank you.
John from Huawei, and I support this decision because I think the the implementation and deployments are there. So I think the context is mature, so it could be better to move forward. And though there are some needs inside the draft, so welcome to contribute to the draft. Yep.
Thanks, Jimmy.
Satoru Matsushima, SoftBank. As an operator already deploying SRv6, I really appreciate this work, and I hope this draft moving forward. And as these drafts define the orbit at the header of the SR header, I think it would be good to keep the name of OEM with SRv6, not to change the others.
Okay, so Bob and I have talked with the Spring chairs in the past about this, and it's always a little hard to find where the right home is for these documents where we collaborate with Spring. We are happy to take it on here, but I think the gating factor is, of course, do we have enough interest in the working group to work on this document here, or should it be done in Spring? And it's pretty much a matter of how many Spring people we get in combination with 6-man people in this room. So before we do an adoption hum, I just get a set of hands that of the people that are willing and interested in working on this? Oh, fantastic. Good. Excellent. So, Jory's in. Do you want to take that call first, or should we do the hum? No? Yeah.
One other thing for the record, I mean, I did ask specifically this question to the chair yesterday, and it's on the recording. They were perfectly happy to 6 men to work on this in 6 men.
So, Eric, you had a question?
I mean, it's basically defining a bit in the SRH header. I mean, and then what it's used and all that, but that's, I think, to me, that was the key thing.
Yeah. So unless the ADs in the room have objections, they do?
No, Suresh Krishnan, so I have no objection, like for you to do the adoption call, confirm on the list, and then we go
Okay,
on.
super. Okay, so those in favor of adopting this document as a working group document in 6 man, please hum now. And those who oppose adopting this document in 6 man, please hum now. Don't be so silent, people. I mean, there must be one objector. Excellent. Then we will confirm that on the list. Fantastic. Thanks a lot, Safar.
Thank you.
And I think that was the working group documents and the active individual drafts sorted out. The rest of the time here will be spent on lightning talks, 5 minutes each, 4 drafts, very limited time for questions. I think we have a little bit time, right? Or we're just about right, yeah. So, yes, please come up and do the application-aware V6 networking talk.
Okay, thanks. This is Jimmy from Huawei. Okay, call me Robin. So this topic is application-aware IPv6 networking. So IPv6 go on move forward. Okay. So this is the architecture for the application-aware IPv6 networking. Because we know now that the transport network faces the challenge of the bottleneck, because we always the bandwidth is increased, but it cannot get the revenue from this service build. So we think about this, combine the application information with the transport network to provide the better service. So that's, and also the finer granulated service for the better SLA compliance. So this is the purpose. So we think the IPv6 is a suitable tool for the purpose, because here we can see that in the edge node of the network, we can encapsulate the application-aware information. So this application-aware information includes the application ID and the service parameter. So the parameter can be carried by the packet through the IPv6 extension header to the transport network edge node. So the transport network edge node, according to the application-aware information, to map into a suitable the SRv6 path to satisfy the SLA requirement. And also the application information can be copied to the SRv6 extension header. So there's the middle points of the SR path can also to use the queue to satisfy the SLA requirement proposed by the application information. So as the egress node of the transport network, so that's the SRv6 header will be stripped and will go on to forward the packet. And this is the forward path. And the reverse path, maybe this packet is forward from the cloud and to the transport network. This is similar the process. Okay. So this is the information proposed in the draft. So the first we propose that's the application ID, aware ID, it can be carried in the hop by hop header or carried by the ISH header or maybe the destination header, depending on the different scenario. So the application header, we can divide it into the SLA level. That means that's the coarse granularity. And also it can also take some of the application ID or the user ID or the flow ID. So that's is depend on this the different the ID, you have the finer granularity for the application identification. So and also that we also carry the service requirement parameter. The parameter can be the bandwidth, the delay, and the delay variation or the packet loss ratio. Depend on this service requirement parameter, it can map to the SRv6 path or for the queues process. Okay, so this morning we have the 18.6 set meeting. So here that is thanks to the attendees. So that we have the 50 plus the members. So here we have the reach for the presentation and the discussion. So that we discuss the possible application information conveyed through to the network, and also the possible application via service, including the DataNet OEM or the in situ OEM. And also at the last of the set meeting, we do the investigation and the consensus.
1 minute, you want to take the questions before your time runs out?
Okay. Okay. So that's we think this is of value, but because across the area and the multiple working group, so that we would like to apply the mailing list to foster the communication. Okay, that's all.
Did you have any host developers in the room? Because I could see how many of them would be very, very, very concerned about privacy implications of this type of technology.
Okay, agree.
Were there any?
In fact, this morning we talk about this. Yeah, the security and the privacy issue. Yeah, we will cope with it. Yeah.
It was the same question. I noticed the security considerations at TBD. And so I was kind of curious if you had any considerations in your own mind as an author.
These are good questions to bring to the list, definitely.
Okay.
Thank you.
Thank you.
Thank you. Next, IPv6 encapsulation for IOM. That is, yes, we have two of those. 5 minutes. Counter starting now.
Okay, so Shuping from Huawei, I will introduce the IPv6 encapsulation for IOM, and also this also involves the enhancement for the IPv6 extension headers. So the current solution for supporting the IOM is to place the IOM data into the hop-by-hop options header and the destination options header. But there may be a risk if we do it in this way. We may push the routing header out of the parsing window on the chipset. So our proposal is to separate the instruction part and the recording part. We define the uniform IPv6 service option and as to carry the instruction part of the path services. And that depends on the path. If all the nodes along the path are IPv6 enabled, we could place the instruction part of the path services in the hop-by-hop options header. And if some of the nodes along the path are SRv6 enabled, and we would like to monitor the network performance of the SRv6 path, we could also place them in the SRHTRV. So generally, the instruction part of the path services, they are fixed. So that could facilitate the hardware processing. We also define a unified container to carry the recording part. And that is to record the service metadata of the IOM and also probably other path services. So that would enable us to stop recording when we found there are already too much data. So that could avoid reaching the hardware limitation. And so we could find that there are more and more path services that require to process the information carried in the packets, and such as IOM. And we would like to the operation on the IOM to be performed in a hop-by-hop manner, but at a wire speed. However, currently, probably due to the lack of service requirements, as well as the limited hardware processing capabilities, maybe. So the hardware, the hop-by-hop options are usually assigned to a slow path.
So that will reduce the forwarding performance. And also along the path, if the devices are from different vendors and they may have different handlings of the hop-by-hop options header, so that will cause the end-to-end service inconsistency. And so the desired processing procedure is not there in the current existing specifications.
2 minutes if you want to take some questions.
Yeah, sure. So can we do it? Can we solve it by configuration? And there may be a few things. So if we done that in this way, so one thing is all the options in the header may be treated in the same way. Another thing is if we do some engineering on each option tab, we need to check against those options one by one. So that is also not very friendly. So we propose to have an enhanced hop-by-hop options header, and we place all the options that require to be treated at the wire speed in this header. And then accordingly, we will need some specifications. And for the IPv6 metadata header, and that is a unified metadata header, and that is used to carry the metadata. For the location, we recommend to place it after the routing header, but there are still two options. For these two options, we need to consider the interaction of this metadata and the other, like a authentication header, ESV, and a fragment header. That's it.
I think we have to run, do you want to run through the questions or the microphone line so we get some feedback on this? I think that's valuable. We have 40 seconds, so please go.
Okay. Greg Mirsky, CT. I share your concerns, and I would suggest you, rather than putting data in a packet, look at the proposal in IPPM working group that called hybrid two-step. It puts in a train packet which shares the same encapsulation, which ensures that it traverses the same path as your trigger packet. So you use your packet to trigger measurement, and you put your measurements in a follow-up packet. You're not concerned about size, and you're not concerned about getting out of fast memory. And the process described in the proposal allows you to have multiple packets follow the trigger packet. So
very quickly, Frank.
Yeah, Frank Bruckner. So real quick, we had a discussion on encapsulation of IOEM and V6 in 6-man last time, and we had another discussion in IPPM this time about how to go and kind of co-work between these two working groups, very similar to the spring 6-man arrangement. And from my recollection of things, is the conclusion is to progress the work in IPPM first, and then update 6-man and liaise to 6-man once we progress the work there to a maturity level, and then ask for review here. And I do believe that with that in mind, the work should belong into IPPM first.
Okay, thank you. And you have 5 minutes.
Yep, lucky day. Good afternoon, ladies and gentlemen. And today my topic is path segment encapsulation in SRv6. So basically we have introduced a path segment in SR pairs because we do need a path segment to identify the paths. But why do we need the path segment in SRv6? That is a question, right? Because the seed list, we all know that the seed list, we can use that to identify the path. But think about it. For the packet A comes from the path 1, which carries the seed list, contains such as 4 seeds, and you have to scan the whole 4 seeds to get the ID to identify the path. And regarding the second packet, such as packet B, comes from another path, which has the more than such as 6 seeds, and then you have to use the ID, which is more than 6 multiply 128 bits as an ID to identify the path. It's crazy, right? But so that is the reason why we propose a fixed length ID, which is called path segment to identify paths, and it would be inserted in the specific location, which is the last entry in the seed list. So that is the main idea. let's take a look at the format of per segment, SRv6 per segment. Basically, we propose two formats of the SRv6 per segment. The first one follows the format of normal SRv6 seed, which has two parts. The first one is located, and the second one is function ID. By the way, you can add some information such as arguments into the seed. And the second one is we can use a global ID to identify the SRv6 part segment, and the specific format of it is based on the specific use cases. So that is the main, almost the main idea of the SRv6 part segment. And I will not go into the details of the processing of SRv6 part segment. And by the way, we have done some work on control plane, such as PCE extension and BGP extension, and comments are welcome.
Which node consumes this data?
Sorry?
Which node consumes the data?
The egress. And by the way,
why is it not a destination option if the destination processes it?
First of all, we can get the pass ID very quickly in the router header instead of destination option header. And then I am pretty sure that the fixed length and in fixed length information in a specific location will have a much better processing performance than the TLV in the destination option header.
If that's the case, when is it appropriate to use a destination option header if it's not for information to be consumed by the destination?
That would be an option. That would be an option. Let's talk about this offline. Thank you.
Robin from Huawei. Ron, I think that's an option, but we would like to keep the integrity of the SRH. Would like to keep it in the SRH.
Yes. Thank you.
Thank you. Fantastic. Thank you. You managed in 4 minutes. Okay. Then it is Safar again on IOM. And you have 5 minutes from now.
Thank you. So I am going to go over a graph that is similar to what Shupeng was mentioning, but in the context of network that are SRv6 capable. The one of the, and I'm presenting on behalf of my co-authors, one of the issues with IONM, and we went over a lot of discussion with respect to collecting data, is availability of data on a given node. Is node capable of recording the data? And do I need the data from all the node in my network? And if I start probing in-band on all the node in the network, would I cause a problem for deviating from the very set of data that I'm trying to collect? So overhead as I go and start collecting this data. If I'm sitting in SRv6 network, segment endpoint has a very reason that I'm going through a segment endpoint because there is a topological reason to go through it. It's an interesting point. And can I just collect data from segment endpoint only? And can I only collect data from segment endpoint data capable of recording the data? So all of these questions are answered by this draft. By using the network programmability notion of SRv6, you can only collect data that are capable. A node which is not capable of recording the data does not have to look into TLV. It will bypass everything. It doesn't have to always look into and scan the data. So main point in as we collect IONM data, we should make sure that we are not affecting the very stream that we are collecting the data from. And I believe that this draft is very useful because it can collect from a very strategic points, and it can only, and the nodes that are not capable of recording the data can skip the TLV processing, which is expensive. At the moment it's lightning talk, so we'll just like to hear feedback from the working group.
Fantastic. That is 3 minutes and 52 seconds. The prize
Thank
goes
you.
to you, yes.
Thank you.
And the last lightning talk we have is on .NET SRv6 data plane encapsulation.
This is Xuesong from Huawei, and I will give a very brief introduction about our work on .NET. Actually, the basic idea of .NET is quite simple. For some critical service or flows, the current network is not good enough. We want it to do better. For example, bounded latency, extremely low data loss, and low jitter. So we have to make the network do better with a group of new technologies. Thank you. Why the network is not enough? For example, in the network, there is congestion, which can cause the latency and congestion loss. So we will use resource allocation along the path for the .NET service, and we also use queuing management for the .NET service, and also if there is other loss because of media errors or equipment failure, we will use a service protection. That means in some particular node, we will do a packet replication, and the packet, after replicated, will go along different paths through the network. And in another node, the redundant packet will be eliminated, and the left one will go through. And also, to make the .NET service stable, we also have to rely on the explicit path. This presentation is about how to implement .NET in an SRv6 domain. Here are some requirements for the SRv6. For example, the first one, we have to identify in the SRv6 payload type. And also, we have to find a suitable explicit path for the .NET flow. This is supported by SRv6 naturally. And in order to do the service protection, as mentioned in the previous slide, we have to indicate the packet, do packet replication, elimination, or the ordering function. To implement these functions, we require extra information, for example, the .NET flow identification and sequence number. And also, we have to use the SRH to carry queuing and forwarding indication to do congestion protection, but this part is not covered in our current version of the draft. What can we do? We list some options to do this, especially for carrying flow identification and sequence number. We can carry it in SRH TLV. We can carry it in the segment list inside a seed to define new functions and arguments. Also, we can define a .NET seed, not for routing, just for .NET service. This is all of my presentation, and why I bring it here is that I think this is a very interesting example for people to see that what can we do with the SRv6 and SRH, and perhaps we can have good feedback from the 6-man working group. Yes, please.
Ole Truan. So I got dragged into being the Loops BOF chair earlier in the week. And this reminds me very much of the problem statement that Loops had. And of course, they're doing as a non-working group forming BOF. But I'm sure they would, and probably you would as well appreciate it if you could have a look at their problem statement and perhaps post your draft or subscribe to that list, because there looks like there's a lot of overlap in the problem they're trying to solve. They're not solving it with, or at least, they're just in the problem defining stage, but they weren't thinking of solving it with SRv6, but it certainly looks very much like the same problem.
You mean loop local optimization, right? I think it's not similar problem because loop. I think the problem for loop is that it want to bring some flow control method between the edge node of a domain. But for DataNet, I think it's not the same.
We're done, it seems.
Okay, thank you.
Thank you very much. So we have completed the agenda and we're about on time. So thank you very much, and we will see you all in Singapore.
And if anyone can bring the blue sheets up to us, that would be appreciated. Does anyone have the blue sheets? They're missing. No, they're gone. Someone stole them. I can see one of them.